Good morning, everyone. Good morning, everyone. Good morning, everyone. Today we are going to code Wolfram language Mathematica. This thing, animation of a cycloid curve. So you draw a circle with a dot on the rim of the circle. Then it will trace out this curve. This curve is called cycloid. You can find it by just search for spatial visual dictionary of spatial plane curves. Then you scroll down cycloid. Then you can see this animation. So today we are going to code this animation. Let me show you my keyboards and let's have a drink. So this is gonna be slow. If you are watching this offline, feel free to skip around if you are watching it not live. So I'm having some drink, red wine with apple juice. And my keyboards, Glove 80 keyboard, fantastic. Ultimate hacking keyboard, fantastic. All these I recommend. This is Nulia trackball, and this is Logitech G502. Nulia 501, M501, I think. So, and again, let me show you this. This is the most fancy keyboard called Svalboard, Svalboard. If you search it, you'll find it. So I will be using it. So I just want to tell you again, and I will be using it daily. Okay, Svalboard, fantastic. Check it out. Search for it. Okay, so that is me, and now let's get to Wolfram language coding, serious coding. Okay, if you have questions, comments, ask. Okay. Okay, so Wolfram language. Okay, for those of you new here, let me just show you. If you search for XR Wolfram language tutorial, you'll find it. The most high-level language than them all. And then you can click on download. This is where you can download the Wolfram language engine so you can play with it, or you buy a Raspberry Pi, it comes bundled with it, or just pay Wolfram and buy it. I do recommend it. Okay, so that's how you download. Then you have all these tutorials. This tutorial, my tutorial on Wolfram language, is for programmers. So if you are familiar already with the language Python, Golang, PHP, JavaScript, or even C, C Sharp, or Haskell, you can learn programming Wolfram language, introduction, print Wolfram language version, building help, find function, that's introductory sections. Then you have how to comment code, then you how to print anything. Then you start to have data types, string, how do you do string, and regular expression, and then other things such as number, arithmetics, add, plus, minus, number input format, and hexadecimal, and arithmetics, and then Boolean, and if statements, and conditional, and loop, iteration, and function, how do you define a function, and so on, and data structure. So XR Wolfram language, XR Wolfram language tutorial. Okay, that will get you started. Down, you can now, it's free for like 4 years. Okay, so begin coding. So let's see today's talk show, and what. So that so let me. So this is what we are coding. Okay, the cycloid. This curve is very interesting. So maybe let me do some explanation. Should I, or should I directly? Yeah, let me tell you why this curve is interesting. This curve is a very famous curve. If you search for cycloid, you'll find YouTube or other information all over. In math departments of universities, you'll find lots of pages. Cycloid. It's a very famous curve. And this curve is meant to solve a problem. So let's use the pen to draw. So let's see. For example, if you have a you cannot draw here. So okay. So I need where is the, yeah, okay, so you need the Microsoft screen snip. Okay, so let's just snip that. Okay, so let me draw and show you so you can see. Yeah. Okay, anyway, so if you have a line, straight line, if you have a ball, let's say a small metal pellet, a small marble, and if you drop it, it'll run down, right? So the question, a very famous question around 1800s, I think, or was it 1700? So the one of the famous question is that what kind of curve will let this ball drop from point A to point B? Point B is below point A, the fastest. So you can have all kind of curve. You can have this curve, or you can have like very sharp and then slowly go to point B. Then, or you can, you can have this way. Obviously that way is slower. So I mean, so the question is, what is a curve that will let a ball drop down purely by gravity the fastest? Okay, and the answer turns out to be a cycloid. Okay, the answer turns out to be a cycloid. It's this curve. So this curve can be generated if you just roll a circle, put a dot on the rim of a circle, or a wheel like a car or a bicycle. For example, on bicycle today you have LED. You can buy a LED light bulb on the rim of the bicycle. So when you ride it, it kind of traces out this. It traces out exactly this curve. Okay, it's called cycloid. So once you trace out this curve, then you just invert it. So this curve, where is our drawing? So that, so that basically looks like that. So that curve, if you put a marble on, from one end to the end, that marble will roll down the fastest. Okay, so it was a famous problem in 1800s, I think, and the solution is the cycloid. In fact, you can look up Wikipedia. Wikipedia will tell you. In fact, the name of the problem is called Bronkenstein or something. Okay, so cycloid. By the way, Wolfram research math word is not good. Okay, Wolfram research math word is not a very good, reliable, accurate resource. So whenever you want to read about mathematics, Wikipedia is better. Okay, so they showed this too. I did this. So I did this, in 1997 or 96. But today Wikipedia has, they also have it. So anyway, so they show the history. You see, so if they have an animation showing different kind of curve, which one is the fastest? So this black one is the cycloid, and you can see it arrives to the bottom the fastest. That's the solution. So in order to solve this problem is technically called calculus of variations. So you need to use a lot calculus to, in fact, it's advanced calculus. Okay. So cycloid, okay, so that is the story. And what's the name to this problem? Let's see. The cycloid has been called the Helen of geometers, as the Helen of Troy, blah, blah, blah. Oh, I never heard of that. So it's called Totochrome or something, the problem. So let me find what is the name to the problem. Let's just search for chrome. Yeah, okay, there it is. Brachistochrome curve. So it says here, the cycloid with the cusps pointing upward is the curve of fastest descent under uniform gravity. Okay, so you can click on that article and you can see there's a dedicated article for this problem. History, Galileo's problem, 1638. Oh, so back to 1600s. Yeah, 1696 is a solution, more or less. Okay, so Cycloid. So today, so I wrote these packages to generate those animations. So here is a package Tracoid. Now Tracoid is a special case of Cycloid. So let's open it. Okay. So I was going to update these my Wolfram language packages, but I thought it would be better if I actually just let's expand order. Okay, so continue with updated styling. So what is Tracoid? Okay, so let's see what is this. Oh, this is the Tracoid. Okay, so not this one. We talked about this one 2 weeks ago on my YouTube. This is the so-called spiral graph. Okay, so not this one. Okay, so we don't want the Tracoid. Let's see. Actually, it's somewhere there. Let's see, what is this one? Control Shift left bracket. Okay, so that will expand. Wait. Okay, continue with the current setting. Select all. Control Shift expand all. Okay, expand all cells. Okay, this is also not doing what we want. I have a Cycloid page. Okay, so yeah. So originally I was going to update those packages, but I thought it's gonna be boring for you guys because it's mostly just me working on those. So why don't I start from scratch and show you how to generate this animation? Okay, let's begin. Let's just start to do that. Comments and questions, ask it. Okay. Okay, so we start to code Wolfram language. Okay, I'm using Xafly keys. I'm using Emacs Xafly keys and Vorak keyboard layout. Okay, so this is, and currently I'm using Xa Wolfram mod, which allows you to code Wolfram language in Emacs. Okay, close that. We don't need it. Okay, so let's go to. So let me show you. So what we're gonna do now is to show how do you generate an animation in Wolfram language, and then you can export it to varieties of movie formats. You can export it to GIF and so on, GIF or MPEG-4 or AV, AV something file. So okay, so how do you generate a animation? So the most fundamentally what you have to do is you create a graphics, you create lots of graphics, a sequence of graphics that forms an animation. Okay, so let's just do it. Okay, graphics. Okay, let me show you. So graphics, and let's say rectangle. Okay, let's say, yeah, okay, let's say rectangle. Rectangle requires a parameter that's the one corner of the rectangle, and the other corner of the rectangle, let's say 2, 1. Let's see how that works out. Okay, I think that's it. Now we have no idea what are the coordinates, so let's put a coordinate. So axis, true. Shift enter. Okay, so now we got the idea of where the coordinate lies. Okay, now let's say I want to create a sequence of these rectangles where they get longer and longer, let's say. Okay, so what we can do is use a table. So table takes 2 arguments. Can you guys see me? Yeah, okay, you guys can see it. Fantastic. Comments and questions, okay? So a table, so first of all, you need So you just do like before. You need a graphics. Then the second argument is a list. Not that. So the second argument is a list of variables. X goes from, let's say, 1 to 5 in steps of 0.0, 0.2. Okay, so now the second point of the rectangle, instead of 2 to 1, is going to be x and 1. Okay, so this will generate a bunch of graphics, a sequence of graphics. Shift enter. So you go down, so you can see, each one gets longer and longer. Okay, so that's essentially an animation already, and you can export this. But before we export into a movie, let's make the plot range fixed so we can actually see the rectangle changes its length. So again, this is the fundamentals of creating an animation. Okay, all you have to do is just generate each frame. Then we're gonna do this cycloid. But this is the fundamental elements of how do you create an animation in Wolfram language. Okay, so now we need to fix a plot range. Let's say plot range. I don't think it's here, but let's just try it here. Okay, so plot range is an option to the graphics. So plot range takes a list of 2 points. So the first point is 0 to 0, and the second point is, let's say, x-axis is 5 and y-axis, let's say, 1.5. Okay, let's see. Shift enter. Okay, that doesn't work. It doesn't work because the plot range is not an option of graphics. So if you understand what I mean. So let me show you. Copy that, paste it here. So let's put it here so you can actually easier to understand. So you have, we have a graphics function. Then then we are giving it 3 arguments. Rectangle, which is a graphics primitive, exactly what you want to draw, and axis true is is an option for the graphics. It tells you that we want axis, but plot range is not. This plot range is not option of graphics. So that is why you are getting these empty things. So what we need to do is, if you want a plot range, what you have to do is you can do this. Let's see. Plot range. Okay. So how do I know? Well, I know because I've been coding Wolfram language for like 10 years. So you can find out by options and options graphics. Okay, then it will tell you all the options for the function graphics. This applies to any function, every function. Okay, so you can see plot range is not here. Oh, it is. Oh, okay, so actually we got something wrong. My mistake. So why is it all empty? Let's see. -1 to 1, 0 to 5. Oh, I think we got the plot range wrong. Plot range. Oh, yeah, obviously we are saying, so the first element, so the first part of plot range is the x-axis. So it should be 0 to 5. Okay, then the y-axis 0 to 2. Okay, that should work. Do it. There it is. You can see now you see the rectangle increases length. Exactly. That's exactly what we want. So now we essentially got the animation. Well, we got the list of images. Now we just do that. You can do is list animate. Okay, so this function list animate will take a list of anything. It will turn it into an animation. Okay, so we can just Control L to copy the previous input, then Shift Enter. Then we got a fantastic animation and interactive too. Let's make it cycle backward and forth. So that's how you generate an animation. In summary, you just create a list of graphics and using the table function, very convenient, and feed it to this animate. Then if you want to export this, or you that's very easy to into a movie. Let's export into a GIF. So you just say export, okay, then export, this table thing. Then the first element of export is the file name. Okay, so let's give it a file name. The file name will be test movie. Okay, .gif. So if you have a file name extension of GIF, Wolfram language will figure it out. It will expect that you want this format to be GIF. Okay, let's do it. Shift Enter. Okay, it's done. Now, where is it? It's in the documents folder. Okay, so you go to the documents folder. There it is. Okay, let's open it. Fantastic, a GIF animation, fantastic. Then you can share this on Twitter, on whatever, Instagram or whatever, Facebook or whatever. It also supports lots of formats, like all possible formats ever. So let's why don't we try WebP? WebP is a new format from Google 10 years ago, which supports animation. Okay, so go to the documents folder. There it is. Open it. So it opens in browser, WebP format. And you can also save it to MP4. Okay, so close this. We close that. I don't want to close the whole browser, but anyway. So let's do it again. This time MP4. Okay. Shift Enter to create it. Okay, MP4 takes a while, so there it is. Open it. There it is. MP4 movie. Fantastic. Okay, so that's the fundamentals of how do you create an animation. There's lots of other ways too, but this is one of the way. Okay, so now we just going to create this. All we have to do is just generate a sequence of these images. Okay, now this will take some effort. Let's see, I've been talking for 20 minutes already. Okay, let's try to do it. Okay, so I'm going to do this in Emacs because it's much easier for me to code here. So let's generate a sequence of images of a circle rolling on a line. A point on the rim of circle traces out a curve called cycloid. This is what we will do. Okay, that's a kind of description. Okay, so first of all, we generate a circle. Okay, so circle takes a center. Okay, so the circle takes a center. So in each animation, we need to know how the circle move. Okay, so let's say XY and the radius 1. Okay, so that's then we rectangle this part we don't need. Axis true. Plot range we need. Okay, so plot range is going to be, let's see, the circle of radius 1. Let's see. Okay, so moving from, okay, plot range, so the x-axis will be, let's say, -1 to 6, okay. The height, the y-axis will be, let's say, -0.5 to 1.5, okay. The radius is going to be 1, okay. Well, if the radius is 1, you need at least 2, okay. So let's say the height is 2.5, okay. So we have these graphics you can show, you can show it, it'll show, okay. So, well, xy is not defined right now, so you can just say 0, 0, okay. And it's red, so red means something is wrong. It's evaluated, yeah. So wait, why is it CIRCLE? Did I spell it wrong? No. Let's see, did I, it was a parameter wrong or what? CIRCLE. So here's a Wolfram documentation for circle. Why is it CIRCLE? What? What's going on? Let's see, error messages. An improperly formatted option was encountered. Oh, I forgot the comma. You need a comma after the circle, obviously. Okay, comma there. Evaluate it. There it is. We got the circle. Okay. Okay, so the circle, so the XY is the center. Let's see. So we got kind of one frame. Well, we also need to draw so we kind of got the center. We also need to draw a dot on the circle. So, okay, so let's, a dot, how do you draw a dot? It's just a dot, okay? And see, yeah, you can actually read the documentation. No, no, not dot. What is it? Point, okay? So actually it's a point. Point is one of the graphics primitive. It will draw a point. So here a point on a dot. Okay, so in the beginning it's actually we don't know where it is, but okay, we'll figure it out. So the essence, you see, we already know what is the where is that? God, we know how to do this animation. I mean, we know how to do animation in terms of Wolfram language. Now, the problem we have at hand right now is about the mathematics of it. That is to figure out where all the points and all the dots are in each frame. Okay, so these are just the graphics. So the main thing is about the center of the circle and the dot. Okay, so the center of the circle is actually pretty easy. So let's see. So we need a parameter, let's say t, that moves throughout. Okay, we need a parameter that moves throughout. Then, so as the parameter t changes, the circle center changes, and that dot position also changes. So what is this? This is the parameter. Okay, so actually, so this is the position of the dot. Okay, t minus sine t, and y is y minus cosine t. That is the position of the dot for each frame with respect to t. Okay, then Okay, then what is the center of t? I mean, what is the center of the circle? Something simple. So, but I don't know yet. Okay, so but anyway, let's try to code this. Okay, so the point is that. Okay, then you need a table. Okay, table, two parameters. Okay, the second parameter is the variable, the varying variable. So t goes from 0 to 2 pi, I suppose. Okay, the first argument would be this block. Okay, so now we got, and the center of the circle, we don't know what it is yet, so let's just say 0 0. Okay, I mean, let's just get something going visually so we can actually have some kind of progress. Okay, so okay, you got all errors. T goes from 0 to 2 pi. Yeah, okay, yeah, obviously this is wrong because a point just take x and y. It doesn't have extra coordinate 1 there. So you need to remove this one. Do it. Okay, more still error. So what is going on? Let's see, what is the error? An improperly formatted. Oh, okay, I know. Well, so graphics takes 2 arguments. Right now you have 1, 2, 3, 4. So that is incorrect. I mean, the first argument is a graphics. So in our case, we have 2 things. One is a circle, one is a point. Each one is a graphics primitive. But the graphics function allows just 1. So when you have more than 1, you need to put them in a list. Okay, so a list. Okay, like that. Okay, copy it. Let's do it here. Select, 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 paste, and run it. Fantastic. So we kind of see, you see the dots are moving. That's a good sign. So we just, yeah, so 0, t goes from 0 to 2 pi in increment of 1. That's too big. So we add a steps. Let's say 0. Let's say 0.2. Okay. Evaluate it. Fantastic. I think we got something. Okay. So let's put more steps so we can actually see 0.1. Evaluate it. Okay, it kind of, yeah, it's going. Okay, yeah, it's kind of is going. So we can do this again by list animate like before. Okay, then copy the above input, run it. Fantastic. You see that dot is tracing out a cycloid. Next, we need to figure out where is the center of the circle with respect to the parameter t. Okay, it's the next step. Almost done. So that's just this thing. Okay, you know, the last time I did this is like 25 years ago, so I don't remember what it's. So now this is the part you need to think about trigonometry and math. Okay. So well, I mean, we can. I mean, another way is just like trial and error. So that will never work out. Okay. So let's see the x-axis. Let's just say t for now. Okay. Then the y-axis. Actually, that makes sense. The y-axis will be 1. Okay, because the radius is 1. Okay. So let's try that. 0.1 steps. Okay, so cut, paste, and let's do list animate. just like before. Okay, I mean just like, yeah. So copy that, go back to the Wolfram language, run it. Fantastic. Our guess is correct. Blind guess even. You see, we got the circle going, we got that dot going. So all we have to do now is you need to have a trace of it. Okay, so stop this. So in order to have a trace, you need not just one point, you need a list of points. That's easy, okay? So let's, whoops. So let's, wait. Yeah, so let me make this clear. So this is list of things, okay? Now add a comma, and now you need a list of points instead of that. So let's just use table again. Table, that thing, and a new variable. Let's say x. X goes from, yeah, you need a list of table. Yeah, very easy. So actually, you should be just t. Yeah, actually, you don't even need. So right now we have some efficiency considerations. I'm doing this right now in a very inefficient manner because if we do this table here, the computation is repeated because for each frame, you are computing the point, then you are computing the same point, there's a repetition. So, but let's just get it going. So we, afterwards, then we can think about efficiency. So here t follows the same parameter, t from 0 to 2 pi in increment of 0.1. Again, that's repeated code, which is not good. You don't usually, but anyway, let's not worry about efficiency or elegance. Let's just get this animation done, which is one of the advantage of Wolfram language. It allows you to do things quickly, like 10 times faster than Python. So so here you want the table of points. That's right. So actually, wait. So you want the trace. You see the trace of the dots. You don't want all dots at the same time. Rather, you want, at each time in moment, you want just the back, the history of it. So you don't want this entire thing. I mean, you don't want from 0 to 2 pi. So you want from 0 to t, actually. So let's change the variable here. T becomes x, 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 x. Okay, so here x is a variable. X from 0 to t, t is whatever the current time. So yeah, that actually, I think that's it. Copy it, let's do it. Evaluate. Beautiful, fantastic. Yeah, so right now this animation, although functionally is basically perfect, but you see we are missing visual elements because you can, this animation, when you have a wheel rolling, you need some kind of spoke so that as humans we can visually tell it's actually turning. So in that case, we create a line, we add another graphics primitive, a line. We want to draw a line from where? From the center of the circle to this point, okay? So actually a line, okay? I think that's it. Let's just try it. Let's stop this, do it. beautiful. Okay, I think that's it. Yeah, I can elaborate more and add color. For example, this circle, let's say red. Wait, let's say point, let's make the point red. And let's make this thing pink. Okay, let's say pink. Okay, so copy that. You know, we start to decorate this animation so it becomes more and more beautiful. And you know, then we can increase the length so it rolls, you know, like this one. Okay, but that's it. Beautiful code. You know, we don't want to make it too much. Okay, that's it for today. Thank you guys for watching. If you enjoy Xa Talk Show, pay me. Okay, pay me. Good night. Hey Huang, my loyal watcher. So if you like my stuff, you can. Okay, I need to. This part is marketing part, where every YouTube, you know, takes a minute to talk. So I should as well, because I need money to survive. So you go to xali.info, where you arrive at my, you know, technical website, Xa Code, xali.info. Then all the way down, you'll see Patreon me, PayPal, and Amazon gift card me. Okay, use these links, because if you are in Japan or in German, you use Amazon gift card, doesn't work. It needs to be this one, USA, Amazon USA. Or you can PayPal me, Patreon me, you know, $50, $100, paid one shot. Okay, you know, I prefer, instead of $5 a month, you know, pay me one shot, $50, $100 for a year. Thank you very much. That's it for today. Yeah, I think. Okay, so here's today's code. Let's put it back. Syntax correct, show in browser. So we have today's code and a link to my website, so you can learn lots of these wondrous mathematical curves. Especially if you are young people, you know, you are studying engineering, physics, you know, those are great fields. You know, also for you programmers, you know, if you are studying calculus, trigonometry, these things are great, very interesting. And for programmers, you know, programmers usually, you know, they don't do this. They do, you know, they do OpenGL and gaming, you know, the bitmap graphics, extremely complex, you know. So if you feel like a change of things, you know, do visual programming, but instead of the gaming and things, you know, you can try to do this in Wolfram language or in your favorite language. Okay, thank you guys. Bye. Why don't you use Linux? That's a trolling question, because yesterday we talked about it and we talked about that 1,000 times. Bye guys.